we are discussing fractional function. Now let's discuss some more questions based on fractional function. Now we know the property of greatest integer of x plus I is equal to greatest integer of x plus I. This is the property of greatest integer. So we can write this one as greatest integer of t, greatest integer of x over greatest integer of x minus 2 minus this one will be greatest integer of x minus 2 divided by greatest integer of x is equal to this. You can write x minus greatest integer of x plus 12 divided by greatest integer of x minus 2 into greatest integer of x. Now simplify by taking LCM. So this can be written as what? This can be written as greatest integer of x minus 2 into greatest integer of x, and here it will be greatest integer of x whole square minus this will be greatest integer of x minus 2 whole square is equal to 8 times x minus 8 times greatest integer of x plus 12 divided by greatest integer of x minus 2 into greatest integer of x. Right. Greatest integer of x minus 2 does not equal to 0 and greatest integer of x does not equal to 0. These are in denominator, so these values cannot attain. That means from here it is what? Greatest integer of x does not equal to 2. So from here x will be what? X does not belongs to what? Greatest integer of it is 2 to 3, and from here x does not belongs to 0 to 1. So from here it will be what? This we cancel out, and this is greatest integer of x whole square minus greatest integer of x whole square minus 4 plus 4 times greatest integer of x is equal to 8 times x minus 8 times greatest integer of x plus 12. So this will cancel out. Now what is remaining here? So this will be how much? 12 times greatest integer of x. Take this to left hand side. It will be what? 12 times greatest integer of x is equal to 8 times x plus 16. So this is 3 times of greatest integer x is equal to 2x plus 4. So this is coming the final equation. Now we can solve this equation. We can solve in many ways. Whatever the equation, whatever the method you want. So this can be solved by this is what? 3 times greatest integer of x is equal to 2x plus 4. Now this is greatest, this can be written as what? Divide by 3. Now greatest integer of x is less than or equal to x and greater than of x minus 1. By using this we can find the expected interval in which solution can lie. So this one can be written as x minus 1 greatest integer 2x plus 4 by 3 is less than or equal to x. So this is x minus 1 less than 2x plus 4 by 3 intersection 2x plus 4 by 3 less than or equal to 1. So this is what 3x minus 3 less than 2x plus 4 intersection 2x plus 4 less than or equal to 3x. So this can be written as x is less than 7 intersection from here x is greater than or equal to 4. So if you take intersection you will get 4 to 7. So this is the expected interval in which solution can lie. Now next one is here it is the expected interval. So we can solve this by taking different type of intervals. So here we are getting x does not equal to 2 to 3 and x does not equal to 0 to 1. So now let's solve this one. So here we can choose x greater than or equal to 4 and less than 5. If x lies between 4 to 5, then if you take greatest integer of this one, greatest integer of x is equal to 2x plus 4 by 3. In 4 to 5, if you take greatest integer, it will be what? 4. So 4 is equal to 2x plus 4 by 3. So it will be 12 is equal to 2x plus 4. So x will be how much? X will be 8 by 2, that means 4. So this is the one solution. X is equal to 4 is the solution. X equal to 4 does not lie in this interval. So this is our solution. Now next, if x is greater than or equal to 5 and less than 6, then if you take greatest integer of this one, greatest integer of this will be what? 5. So here 5 is equal to 2x plus 4 by 3. So this will be 15 is equal to 2x plus 4. That means x is equal to 11 by 2. 11 by 2 is what? 5.5. 5.5 does not lie in this interval. So this is also 5.5 also lie in this interval. So this is second solution. This is the first solution. Next, if x lies between 6 to 7, then if you take greatest integer of this, then greatest integer of this will give you 6. So 6 is equal to what? 2x plus 4 by 3. So from here x is equal to what? X is equal to 7, and 7 does not lie in this interval. So this is not our solution. So final solutions are coming what? As answer is what? X is equal to 4 or 11 by 2. This is our final solution of this one. Now let's say solve this question. So how will you solve this question? First of all, see here, if you take common factors of each, so this will be what? 2. Take 3 from here common and 2 from here common. So this will be numerator, it will be 6, and this will be fractional function x minus half. This will be fractional function of x minus 2 by 3. Divide by fractional function x plus 3 into this will be 3 here, and fractional function of x minus 4 by 3 greater than or equal to 0. So this is what? 2, and divide 2. So this will be, this is our inequality now. 2 is a positive number, divide this by 2, inequality will not change. So this is our inequality. To solve this one, same, to answer will be same from here. So we know the property of fractional function lies between 0 to 1. Fractional function always lies between 0 to 1. So this, if you substitute value of fractional function which lies between 0 to 1, this will be always negative number. This is always negative number, and this is always positive number. This one will be always positive number because fractional function x lies between 0 to 1. If we substitute here any value between 0 to 1 and add 3, it will be always plus. So in wavy curve method, this will not change sign, this will not change sign. Multiplication of these two will be negative. So multiply these two, right hand side inequality will change because product of this is negative. So this will be what? Fractional function x minus half into fractional function of x minus 2 by 3 less than or equal to 0. Now apply wavy curve method. Solve it by using wavy curve method. This is what? 1 by 2 and this is what? 2 by 3. This will be plus minus plus. And this will be what? Included. This will be included. So fractional function of x will lie between 1 by 2 to 2 by 3. And we know this one, fractional function of x will be equal to x if x lies between 0 to 1. Fractional function x will be x if x lies between 0 to 1. So this will be what? X less than or equal to 2 by 3 and greater than or equal to half. That means x belongs to 1 by 2 to 2 by 3. So this is our final answer of this one. Fractional function x can be written as x if x lies between 0 to 1. So this greatest integer x, this fractional function x is what? In between 1 by 2 to 2 by 3, which include this interval. So this can be written as like x. So x will be what? 1 by 2, 2 by 3. So this is our final answer. Now let's solve this question. How will you solve this one? First of all, find roots of this one. Let fractional function x is equal to t. So this can be written as 4t square minus 7t plus 3 greater than or equal to 0. And 4t square minus 7t plus 3 is equal to 0 gives you the root as 7 plus minus of root 49 minus 48 divided by 8. So this will be what? This will be 1 or it will be 3 by 4. So this can be written as 4 times t minus 1 into t minus 3 by 4 greater than or equal to 0. Now what will be solution of this one? T will be what? Less than or equal to 3 by 4 or t greater than or equal to 1. What is the value of t? It is fractional function x. Now substitute here fractional function. So this will be fractional function x less than or equal to 3 by 4 or fractional function x greater than or equal to 1. Value of fractional function x cannot be greater than or equal to 1. So from here x will be what? X belongs to 5. Now we have to solve this interval. What will be the solution of this one? Solution of this one, we know that this fractional function x is always what? Greater than or equal to 0. So what will be solution of this fractional function x always greater than or equal to 0? That means we can write as this one, 3 by 4. From here we can write as this one. That means x will be greater than or equal to 0 and 3 by 4. 3 by 4. Right? This is in one interval. In 0 to 1. In 0 to 1. Now in general, if we want generalized interval, then add both side integers. So in general, solution will be what? X less than or equal to n plus 3 by 4. This will be I plus 3 by 4 greater than or equal to I. That means x belongs to closed interval I comma I plus 3 by 4 where I is integer. Where I is integer. You can solve this by another method. By what? Substitute, put here x is equal to I plus f in this one. and you can solve as I told in previous questions. So this is the answer for this one. Directly you can write in 0 to 1, answer will be this one. Answer will be this one. But if you want generalized in the whole real line, then add both side integers. So this will be I to I plus 3 by 4. This is the final answer of this one.